So in previous steps 0 and 0a, we've seen how to create a module and execute a module. In this step 0b, we'll see how to calibrate it. As explained in previous step, a module is a piece of code consisting of a Simulink library associated with its calibration script, for example. Most of the time, modules need variables to be executed. The aim of the calibration script is to assign all the required variables to the module. Fundamentally, a module is completely independent in terms of Simulink and variables. In practice, it may not be completely achievable for usually following reasons. A user may use his own Simulink libraries inside a module. Plus, to compute variables, some scripts may use external routines. Then there are some modules that may be fully independent. Some may have their Simulink library user-dependent, and some may have their calibration script user-dependent, and some may be user-dependent in both ways. For example, this is a pure example. In this, for this module, the library is user-dependent. For this module, this is completely independent. For this module, the calibration script is user-dependent according to routines. And for example, for this module, the module is dependent in both ways. This is to say Simulink and routines dependent. The point is that when a module is user-dependent, other users may not be able to correctly use this module. If users sharing the modules are close, they may use same libraries or routines. If it's not the case, for example, a colleague coming from another department, module may not be able to be executed. In that case, there are basically two possibilities. Specific libraries and routines are distributed to, and our module has to become independent. How a module can become independent? There is two ways. First, links to specific libraries are broken, and calibration script explicitly defines variables. This is an example of explicitly defined variables, or some variables may also be assigned using a mat file. And in that case, it might be convenient to put the mat files next to the script, calibration script of the module. Let's go through an example to illustrate this. So suppose that the module CANBIS VU0 uses 4 variables. So for example, let's have a quick look to this module. So as we can see inside the code, indeed there are 4 variables used, which are offset can new rate, scale can new rate, offset can net hack, and scale can net hack. And this is how Simulink proceeds to resolve these variables. First of all, he inspects in the subsystem workspace. It is defined by the mask, if any. Then after that, if it's not resolved in this workspace, variables are looked for in the model workspace. And if it's not found in this workspace, this is looked for in the base workspace. There is of course a main advantage using a mask. This is to say that a same variable name may be used in different modules without risk of conflict. For example, a proportional gain named KP can be used in different modules with different values and the same name, which is very convenient. As an example, suppose that the user wants to use both offset can new rate and scale can new rate inside a mask. Then it's defined that way. If we take a look to the mask, and we can see that we have the ST variable, which is linked to the trigger port, of course, and as expected, offset can new rate and scale can new rate. Both values are 0 at the moment, and we have a look to this variable after. And in the calibration script, the 4 variables are defined, for example, in this way. This is explicitly defined in this example. This calibration script is actually the start of the calibration process. So what is this process? From the calibration script, process determines 3 categories of variables. First, variables required by the mask found in the calibration script. This is this category. Point 2, variables required by the mask but not found in the calibration script. This is this kind of variable. This is required in the mask but not found in the calibration script. And number 3, variables assigned during the calibration script but not required by the mask. In that case, these variables are definitely defined in the calibration script and they are assigned in the workspace base. Then variables from category number 1 are written in every mask of CAN-BIS VU0 in use in Simulink. Variables from category 2 are written as bracket, as empty, in every mask of CAN-BIS VU0, and variables from category 3 are written in the workspace base. And in our example, we can see that these variables are from category number 1 and they are written inside the mask. These variables category number 2, it's not found in the calibration script, and these variables are category number 3, so they are written in the workspace base. The calibration process is reachable thanks to the calibrate button, which is enabled as soon as a module is selected. So let's have an example on this module. We select it and then we push the calibrate button. As we can see, we can find the 3 categories. What happens if a module CAN-BIS VU0 is in use in Simulink model? To illustrate this, suppose that this model, which can be opened by click on this link, uses module CAN-BIS VU0. By clicking on it, there is a mask, and we can see that at the moment these variables are set to 0. So let's go and calibrate this module. Here we go. So we have actually exactly the same layout than before, plus a mask has been found, a module has been found in the whole Simulink thanks to this link. And as we can see, both of these variables which belong to the category number 1 have been assigned according to the calibration script. These variables which belongs to the category number 2 has been assigned as empty because not found in the calibration script. This what has been achieved with the calibration process. Plus, both variables of category number 3 have been assigned in the workspace base, this variable and this variable according to the calibration script. Suppose now that a module needs variables from other classes than classical numeric. As an example, if we open the calibration script of CAN-BIS VU3, so we select it and we open it, we can see that, like the previous version, we find all 4 variables plus these variables which are from other class. And according to the mask of the module, these variables are dedicated to a field in the mask. In this case, and to avoid confusion, some variables are used to assign the true value. To illustrate this, suppose that this model, we click on it, uses the module CAN-BIS VU3, and we calibrate it exactly in the same way we did before. So after having been selected, we calibrate it. So as we can see, these variables from another class, that the classic numerical class, are assigned thanks to their what we call the via variable. As an example, we can see that cal is set according to this via variable, which is definitely assigned in the workspace, in the base workspace. And this is the same, for example, for the cal struct variable, which is assigned in the workspace, in the base workspace. This is what is basically described by this drawing. Note that according to this rule and theoretically, for example, offset can urate should be assigned in the mask through these variables. Nevertheless, in case of single numeric one-to-one, the value is explicitly written in the mask for a better readiness. But still, via variables is always available in the workspace base. What happens if an error occurs during the calibration script execution? To illustrate this, we have this module, which has an error in its script. So if we select it and calibrate it, then we have this following message saying that the calibration script failed and the Simulink error.